Hi, I'm Bartosz from Cyrus, and in this video I will tell you a bit about the most popular amplifier classes today: Class A, Class B, Class AB and Class D. There are lots of different ways to amplify signals, and they've been classified into various classes. The letters used to name these classes really don't mean anything apart from the order in which they were invented. So Class A was first. Everything before the invention of the transistor was Class A. Class A operates all the way through the wave cycle, irrespective of the load. The output device here is constantly conducting, meaning current is constantly flowing through it. It offers very low distortion, but very poor efficiency. It's a bit like trying to water two flower pots at different ends of your garden with a hose that is on all the time. You waste a lot of water as you walk from one pot to the other. In an amplifier terms, that wasted energy is dissipated as heat. In a Class A amplifier, about 75% of the power is dissipated or wasted as heat. So it's a very inefficient technology. That is why amplifiers designed in this technology are either low in power, in which case heat is still manageable, or are huge in size to allow them to get rid of unwanted heat. And heat is not desirable in audio. Components exposed to heat usually have shorter lives, especially electrolytic capacitors, which tend to dry out over time. Let us now move to Class B, which became possible with the invention of the transistor. In a Class B topology, one transistor amplifies over one half of the cycle and another transistor amplifies the other half of the cycle. So it's a sort of push-pull. You have a ground rail in the middle and you're pushing and pulling both ways. Now, that is much more efficient because you're not necessarily keeping the hose I talked about earlier running all the time. You're turning it off and on. However, the disadvantage of this method is that at this crossover junction where you're trying to manage that transition from one transistor to another, you get quite a lot of distortion. This needs to be overcome for use in high-end audio applications. The answer was the invention of Class AB designs. In this case, there is an overlap between the ranges in which two transistors work. So in the area that was prone to distortion, the amplifier is effectively running in Class A. The amount of current in this overlapping area here is called the bias. Class AB offers much better efficiency, between 50 to 70%, and distortion is lower than in Class B. However, it's a trade-off between efficiency and distortion. The higher the efficiency, the higher the distortion, and vice versa. So Class AB is effectively a compromise, but most amplifiers today are designed using this technology. Class D is entirely different. Let us assume that at input we have an audio signal, a typical sine wave represented by this white curve here. What Class D then does is it creates a comparator signal, usually in the form of a triangular wave similar to the yellow pattern on the graph. The comparator signal is used as a reference to convert the sine wave into a square wave, which gets amplified at a later stage. So looking at our graph, the comparator will analyze if the audio signal is above or below the comparative wave. Only two values are required, either 1 for above or 0 for below. The other parameter which is analyzed is how long the audio signal is above or below the comparator wave. So if you look at the resulting square wave in black, you will see two values, 1 and 0, and varying widths at either 1 or 0 values. So what happens is that amplitude modulated signal, meaning the sine wave, is converted into a pulse width modulated signal, the square wave, which can then be amplified using transistors that are simply either on or off. A low-pass filter after the output transistor is then used to convert this square wave back into a sine wave that the speakers can be driven with. What is fantastic about Class D technology is it uses transistors which are either fully on or fully off, with no steps in between, so it's highly efficient and operates at a far lower temperature than other classes of amps. Efficiency can be theoretically 100%, but 90% is achievable in practice with a good design. Class D is often confused with digital because of this, but it's an analog amplifier. D just happened to be the next letter in the alphabet when the concept was first explored. Apart from efficiency, another advantage of Class D is high current potential, which helps drive difficult speakers and helps control reproduction of lowest frequencies. No technology is perfect, and in Class D engineers have to manage the problem of distortion and influence of impedance of speakers on linearity of frequency response. But as with every technology, a lot depends on how a technology is implemented. Cyrus has managed to design superbly sounding and very compact Class D amplifiers. We have developed this technology to such a level that they compare extremely favorably with our own Class AB designs at similar price points. To learn more, have a look at the video about hybrid Class D implementation. It provides explanation of what Cyrus has done to move Class D technology forward. But that's all for now. Thanks for watching.